Well, good evening. It's a great pleasure to be here. I'll start with a warning. I'm a molecular biologist and I'm very out of place here and I'm somewhat awed about the audience. And I'm going to talk today about a study which was really a collaboration with the molecular biologists at our end and sort of the more zoological experts like Adrian. And it's really a story that combines some state-of-the-art techniques, but actually with a lot of armchair sleuthing. What this study really taught us is that today you can sit down and use Google and find an awful lot of things out, and that's what we're going to go through. And really the story is this: it's about the type specimen of the elephant. It's a very relevant topic, I guess, for today. And as the title says, it's about losing it and finding it. It should become clearer. So as I guess most people here will know, given the society you belong to, according to the International Commission on Zoological Nomenclature, basically the starting date of the naming of organisms scientifically starts with the 10th edition of Linnaeus' Systema Naturae. This picture up here. Is there a pointer? There is. Yeah. So the 10th edition, published in 1758, is the starting point of nomenclature. Species have been given their names afterwards, but anything mentioned in here is given its name for good. Now the problem with this book, if you all view it that way, is there are often many, many different samples mentioned for any particular species, and these are what we call syntypes. And it becomes even more muddy because sometimes the status of these syntypes are not ideal. Today, if a species is discovered, of course, there'll be a very nice type specimen and it will be sort of concrete and obvious what it is. Of course, back in 1758, it wasn't quite as much. Many of the things mentioned in the book are actually not even around today any longer. Some of them were never really even physical specimens. Adrian's going to talk more about this later. Some of them were physical specimens, and if you today want to go back and choose which one of these is maybe the most relevant type, the lectotype, for example, how do we go about doing it? And this study is very much about this. Now, these confused species, you often might think they're very small things that no one thinks about, but it's often many of the really major species, the really big things that everyone knows about, because of course if Linnaeus knew about them, they had to be fairly obvious things. And the elephant is a complete classic, right? We have three species of elephant today: the Asian elephant, the savanna elephant, and the forest elephant. Back in 1758, however, Linnaeus basically, in his book, writes about the elephant. He calls it, as we can see, Elephas maximus. He doesn't appear to discriminate between more than one kind of elephant. He's lumping them all together. You can ask yourself, does this mean he didn't realize there was more than one elephant? It's probably unlikely. But he puts them all together. He has his nice entry here, and this is where we derive the information about the type specimen today. So the first thing we can see is that he describes it as being based in Sri Lanka, Ceylon, a somewhat maybe strange locality to give it. And it's actually got itself a little bit of an interesting story here. But because it's based in Sri Lanka, we're fairly certain that Elephas maximus, well, we know it should be given the name of the Asian elephant. So why Sri Lanka? Well, actually, one of our collaborators in this study, Anthea Gentry, actually has a hypothesis on this, and she referred us to here the Acta Anglica, which is the philosophical transactions of the Royal Society, and she refers to a certain Mr. Strachan, whose name appears in here. Now, the beauty of modern digitization of books is that it's pretty easy to find many of the famous books online today simply by Googling. And in fact, if you Google this term, Acta Anglica, you come up with a book that was recently digitized from Harvard. This is not the original publication, but this was actually a summary put together in the early 19th century. It was a collection of many of the early years. You can see it says 1694 to 1709. It's got a beautiful table of contents. This is the original one. They've made it modern. They've hyperlinked it. And Mr. Strachan's name pops up. He was obviously a very productive chap. He writes about taking elephants on page 641. He also just has general observations on Ceylon on page 650, shared with something else. He then talks about tobacco in Ceylon, wide interests. Apparently he has more to say about Ceylon down the bottom on page 711. And there are many, many other interesting things in here, but it's very easy to go there and see what he's talking about. This is actually the page of the book, and it's an account of taking and taming elephants in Ceylon. Anyway, the point is, we think this is the reference Linnaeus was going to. He therefore says the type locality of elephant is Ceylon. Oh yeah, one other minor thing I found while looking for this, here again is the table of contents, next to Bite of a Mad Dog by Dr. Lister. I find it's some forebear of Adrian here, possibly looking at other interesting things. So anyway, if we go back to this text, what do we find? Well, we have Elephas, Maximus, Habitat Ceylon, and then there are several different kinds of descriptions of samples or other things that he says is the type material. These fall into several categories. In red here are actually books. These are mentionings of elephants in various books. Adrian will come back to that. We then have another series of them, which include, among other things, this little interesting statement here, which says Seba. Who was this Albert Seba? And this actually forms the rest of the start of the talk. Albert Seba was a very, very wealthy apothecary in Amsterdam between the turn of the 18th century, so you go 1665 to 1736, and he made a lot of money doing whatever apothecaries do, I guess selling people dangerous things and ground up magic. But he earned enough money that he started to collect himself a very, very large natural history collection. And he became very, very famous on this. After collecting it, building it up, in 1717, he actually sold the whole thing to Peter the Great. Here we go, Peter the Great, the Russian emperor. He then starts building it up again, and Linnaeus, everyone's patron here, finds out about it. This is Linnaeus in his less formal gear. For those of you, everyone's used to seeing him like this, but he had a young, crazy self. And in 1735, Linnaeus goes down to visit Seba. Seba's a very, very famous man at this point. His collection is very, very famous. Linnaeus goes to see the collection and is absolutely smitten by it, by the size of it, by what's in there. And he very, very much decides that he wants to get his hands on this collection. So Seba actually publishes 4 volumes of his massive tome, Locuplatissimi Rerum Naturalium Thesauri. He published this, 2 of them in 1734. Volume 1 is about the plants in his collection, most of the mammals, the birds, the reptiles. He then, and this is actually the one that's most important for our study, because inside this book there is this illustration on plate 111 of a baby elephant, a fetal elephant. Now, this is a very large book, and this is actually a life-size drawing in the original book. Apparently, when Seba made his book, he actually didn't have this in originally, but apparently at the last minute he was invited to visit the offices of the Dutch West India Company, where they had this fetal elephant in a jar of alcohol, and he was so taken by it, he drew it in his book, and it became famous from there on. And actually, I many years ago got a copy of this book, and without having any interest in this study, had seen this and was quite taken by this little drawing. But it turns out it's quite an important drawing, because when the collection is sold at a later date, so Linnaeus publishes his first and second volume, but he then runs out of money, and he wants to publish the third and fourth volume. So what he does is he auctions his collection for a second time. And actually, if you look in the pamphlet of the auction from 1752, there is a Dutch statement that I won't try and pronounce, but it translates into an extra fine, uncommon elephant fetus from Africa, plate 11. Notice the from Africa as part of this thing here. And he publishes it. Linnaeus finds out about the auction. Linnaeus basically somehow persuades the Swedish royal family, the king and queen of Sweden, which Adrian will come back to acquire the collection. It's not clear if they bought it directly or if they actually bought it off people who bought it, but very, very soon it was in Sweden, parts of the collection, including this fetus. And we know it came back there because Linnaeus actually is on the record with this quote: "I am pleased that the little elephant has arrived. If he cost a lot, he was certainly worth it. He's as rare as a diamond." So he really, really very much liked this baby elephant. I'm not sure why he liked it so much, it's not clear. I guess there were not many elephants in jars at the time, and it's nice to have your own pocket baby elephant, I guess. It's like a toy poodle, I guess. But he gets it, he's very, very pleased, and he puts it in his collection. So the important thing about this, though, is that going back to that page of Linnaeus' book, where he talks about one of the samples being Seba, it now is this sample we're talking about. It's the fetus in the jar in the book, which Linnaeus got his hands on. Now, what's interesting about this sample is, despite its age, it still exists. And today, the Natural History Museum in Stockholm actually holds the specimen, and we're nearly certain it is the same sample. There's a very well-documented chain of custody. We know that about 1752 they get their hands on it. The auction was 1752. We don't know exactly when they got it, but it must have been shortly after. Linnaeus actually then describes this particular specimen as part of a description about the Swedish king's collection, and he actually says in it, this came from Seba. A bit later, Björklund describes it when the collection is moved from the original location to the Drottningholm Palace. In 1801, it's given to the Swedish Academy of Sciences, which through time develops into what's going to be the Natural History Museum. And in the Natural History Museum, it's further described by various people, Quenzel, Schwartz, Sundervall, and even in 1942, Bergstrom. So this sample has been there for a long time, and this is what it looks like today. It's kind of sad but happy. It's a very happy-looking dead elephant. Very sad that it's a dead elephant. It's a fetal elephant. I should point this out, right? It's not been born. We don't know exactly how many months old this was. Adrian may have an idea. But somebody had clearly killed a mother elephant, taken the baby elephant, and pickled it. Anyway, this is it today. It's very, very actually beautiful to see it. It's very nice to see it. And this is it when you take it out of its jar. It's actually not in the greatest condition. When we started our study, that I'm going to come to in a minute, what we really needed to do this was get hold of some tissue from this sample. And in general, curators are very, very careful with their material. They don't like to subject it to damage for obvious reasons. And so I spent a lot of time composing a very, very polite letter to the curators about, like, would it really be very nice of you to just give us a tiny little bit, and it would be so wonderful, and we'll do this for the world and everything. And they agreed actually very, very nicely. And when we actually saw this sample, the poor thing has been gutted down the middle. One of its legs is sewn up with string, it turns out, very, very thick string. Not particularly happy. So once we got there, we were able to sample it for whatever reasons. So, but it's there. It's a very important sample, and it is the one from that illustration, which is quite remarkable. You can look at this book from the 18th century and then see it in person. But so anyway, the question is, this is now listed as one of the type specimens for the Asian elephant, Elephas maximus, Elephas, and from Ceylon, that they're calling it. But there is a problem, because as you'll remember, the sales prospectus from the auction says this is an elephant from Africa. And now we have a problem. We can't have the type specimen of the Asian elephant being an African elephant, if this is the case. Now, of course, Linnaeus may have been wrong, and it turns out that several people through time have pointed this out. Sundervall in 1857, Lundberg in 1904, and of course Seba in 1734. And a few years ago, our colleague Anthea Gentry, who's here today, actually started a study on this. This is a picture of Anthea in the middle of her taxonomic sleuth work. And she decided to try and resolve this by actually looking at the sample and trying to decide, can we see from the sample if this is an African or an Asian elephant? If it's an African elephant, then we have to remove it from the type specimen status. If it's an Asian elephant, it's a pretty good candidate for the lectotype. It's beautifully preserved, it's famous, and so on. So she tried several things, including CAT scanning and taking X-rays of the sample. This is an X-ray of the specimen. The problem is, though, it's a fetus, so it's not fully developed. Now, it's very easy to see with elephants once they're born and once they get older, if they're African elephants or if they're Asian elephants. They have the famous differences on the end of the trunk. I believe they have different numbers of ribs and so on. But being a fetus, it's not fully developed, and many of the characteristics we'd like to use, like the ears, like the ribs, they're not actually diagnostic. So despite applying some very nice X-ray based work or scanning, it was not possible to resolve this issue. So her solution was to turn to Tim Littlewood, who's also here today, at the Natural History Museum, and ask him to use the newfangled technique of DNA. And in particular, they managed to take a little bit of the umbilical cord, I believe, give it to Tim. Tim tried to do some DNA-based analysis, in essence try and amplify and sequence some DNA and just look at it. Is it an Asian elephant or an African elephant? The Natural History Museum wasn't able to do it. The sample then actually came to me, and this was about 6-7 years ago now, and it was a very strange story, but I got an email saying, would I mind looking at an Asian elephant? I was doing a lot of work at Mammoth Genetics at the time. This is our Copenhagen Mammoth. And so I gave it a go, and I also failed to get it to work. And at this point, none of us could get DNA from it. We were left with this mystery. Was it African? Was it Asian? And there things actually stood for about 4 or 5 years. Until along comes a gentleman called Enrico Capellini. Now, Enrico is an Italian. He's and he's been working with us in Copenhagen for a long time, and he has a specialty which is not DNA but is proteins. The molecular biologists, the molecular evolutionary biologists have been using DNA for many, many years to identify what things are and to look at the relationships between things. Not many people have been using proteins. Proteins also vary by species. They can be very informative, but technology's been very, very behind, and it's been very hard to get information out of proteins you can use for the kind of work we want to do, whether it's looking at the relationship between species or just identifying them. But Enrico is really specialized in developing the methods to actually push proteins further. And Denmark itself has actually invested an awful lot of work in protein work, and we have some of the world's leading protein research centers. Most of the work is very medical based. It's to look at proteins, underlying disease and so on. But occasionally they allow us to dabble with their very fancy machines and actually try and get proteins from old samples and do things with them. And one of the classic uses, this was a study that Enrico was involved in before, this is a mastodon, the extinct elephantid form. And this is a very, very famous sample from the Americas, because if you look closely, this is a part of its vertebra, and this here is something embedded in it which looks very much like a spear point. So this is a mastodon that was hunted, had a spear in it. Now, of course, people have been hunting things for a long time, but this is a very, very old mastodon. It's about 14,000 years old, and there's a lot of debate about when humans first got to the Americas. This sample is old enough that it falls right on the borderline for how long people have been in the Americas. And if one could prove that this was a spear point, then one could actually say, well, humans were clearly there, humans have been there a long time. You may be looking at it going like, well, yes, clearly it's a spear point because it sticks into it, it's a different colour. That's not good enough for archaeology. They say it could be a tumour, sort of very cylindrical, funny-looking tumour. But what Enrico did was he actually used his protein method to prove this, and he actually obtained proteins from the bone surrounding it and proteins from the actual projectile embedded in it, and actually looked at them and identified the species. Now, I don't really want to go into the details, it's somewhat archaic, but essentially you grind up your bit of bone, you extract protein from it, you put it on a very, very fancy machine, and you run some computational analyses, identify all the proteins, and you end up with these. This is what's called a spectra. It's a bit like a mass spec for anyone who knows much about chemistry. And actually each of these different peaks have got different masses, they've got different amino acid compositions, and you can actually work out the amino acid sequence for each of these things. You can then actually compare that to reference information and identify things. It's a very useful tool these days for identification of everything from what species a book is made out of. There'll be parchment in a book, you want to know if it's cow parchment or goat parchment, or even it turns out human skin parchment. You can use it for this, or you can use it for more advanced questions like what we were doing. But the point of this is that Enrico decides to get the proteins and try again. DNA failed, but where DNA fails, protein will often work. You can get DNA for maybe samples going back 100,000, a million years. Protein, in theory, can go back millions of years. So he basically looks for some proteins, and when he finds them, he then takes what we know about the Asian elephant and what we know about the African elephant's genomes, and then he looks at the proteins he gets and says, is this a protein I can find in the genome of these two species? Yes or no? Normally the answer is yes. When he finds it, he then says, is there a difference in the protein sequence between the African elephant and the Asian elephant? And when he was comparing it, he actually found that there was 5 different proteins that he found information on that appeared to be distinctive between the African elephant and the Asian elephant. And this very, very quickly gave an impression that this sample up here was actually an African elephant, because it was kind of African elephant proteins. Now, unfortunately, this is based on a very small sample size. We have 1 fetus, we have 1 African elephant and 1 Asian elephant genome that have been sequenced. And the problem with genetics is it's not always possible to rely on sample size of 1. So what we then had to do was bring in some other experts. This is a chap called Al Rocca and Yasuko Ishida. They're in the US at the University of Illinois. These are possibly the world's leading elephant geneticists. They have a very large collection of elephants, and they went back and looked for these markers we found and tested in a wide series of elephants if they were fully diagnostic. And it turned out they were. We were fairly certain after looking at a long range of elephants that we actually had an African elephant in the fetus. What we then tried to do was say, well, where did this fetus come from? If it's African, can we narrow it down? Another team got involved. This is Luva Darlen in Stockholm, and his PhD student El, with a long Greek surname I can't pronounce, so we shall leave that. And to cut things short, what Ellen Louver did was they were a new DNA team. They went back and tried to pick up where the Natural History Museum in London had failed and where we'd failed to get DNA out. Now, of course, I was pretty confident they would fail, and I made the very silly mistake of saying, I will buy you 10 beers if you get it to work. Now, that may not sound like much, but beer in Sweden costs more than gold. So, of course, very quickly, Louver comes back to me and is like, yeah, okay. So I have avoided Sweden ever since. But the good news is they got it to work, and what this shows is this is the fetal sample. These are a load of other elephants from different parts of the world, of Africa, West Central, Western, North Central, East Central, and so on. And basically we're looking for anything that doesn't have grey, and this elephant has got grey. It means it differs from our Seba sample. The only elephants that match the Seba sample come from West Central Africa, so we can actually even narrow down where the fetus came from. Now, when we dig back into the history, we actually find that Seba originally saw this at the offices of the Dutch West India Company. That's the Dutch West India Company in Old Dutch, very unpronounceable. When you read about this, you find that it's the organisation who had jurisdiction essentially over the Atlantic slave trade, Brazil, the Caribbean. So the Dutch were sending ships from Holland down to the west coast of Africa, picking up slaves, going across and coming back, just like the British were doing. It makes complete sense in this case they would actually pick up an African elephant because they were going down the African coast. If it had been the Dutch East India Company, it would have been a different issue, but we didn't have that problem. Unfortunately, we can't say which species it was. There are two species of African elephant today, the forest and the savanna elephant, and it turns out that they're actually, at the mitochondrial level, indistinguishable, so we can't actually resolve what it is. But we can say it is an African elephant. It's therefore not suitable for being the type specimen of the Asian elephant, and something has to be done about it. Now with that, I shall turn over to Adrian, who will tell you about how we actually fix that problem.
So if we go back to Linnaeus 1758, in addition to the fetus, as Tom mentioned, there are a number of other references that he makes, and the ones that I've highlighted there in red are references to books by Gessner, by Aldrovani, and by Johnston, and these are not actually references to living specimens, they are references to illustrations in those books. Nonetheless, those illustrations, like anything else that Linnaeus might have listed under the name Elephas maximus, also have the status of syntypes. And if we go back to those old references, there's Gessner on the left and Aldrovandi on the right, and those are, to me, plainly African elephants. You can see that from the shape and size of the ear. You can also see it from the hollowing of the back, the saddle-shaped back, which is characteristic of African elephants. And by the way, it's also rather obvious that Aldrovandi has actually taken a copy, an engraved copy, and then printed it, and so it's come out in reverse, so it's actually the same illustration. The third of the citations by Linnaeus of Johnston, 1650, contains these illustrations, and these by contrast are clearly Asian elephant. You can see that from the size and shape of the ear, the convex back, everything about them. So as Tom touched upon, almost certainly for Linnaeus, he wasn't really recognising these as separate species, or he would have given them separate names. They were all included under the name of Elephas maximus, but since the type locality was Ceylon, which of course is within the Asian elephant range, and since Elephas maximus, virtually ever since it was realised that there are two species, it's been applied to the Asian elephant, we're certainly not in the business of disturbing the nomenclature. We need to find a lectotype for Elephas maximus, which is actually an Asian elephant. But you can see that the original Linnaean description is composite. Now, in addition to the fetus and those illustrations, Anthea, in her work on the Linnaean types in Sweden, encountered this small fragment of an elephant molar. which is identifiable as Asian elephant. You can tell that because of the wiggly nature of the enamel. What we're looking at here is an object that probably represents about 5% of a total original elephant molar. It was worn down in life, it's been cut up for whatever reason, but it is a fragment of an elephant molar, and Anthea has shown quite convincingly that this was a Linnean specimen in the sense that it was present in Sweden while he was working and that he saw it. There you've got a short extract from his report on the King and Queen's collection that Tom mentioned of 1754, where under the name Elephas indicus, which was the name he originally gave, he changed it in 1758 of the 10th edition to Elephas maximus, so that's the name we now use. But included in that, he said that he'd seen teeth of this animal of several sizes. Now, that fragment of tooth is currently in the collection of Uppsala, and Anthea has really shown the kind of chain that links that extant fragment all the way back to Linnaeus. Ulriksdal collection, which is where Linnaeus originally studied it, moved to Drottningholm, and in fact that is the collection room which you can still go and see in the palace where Queen Lovisa had her collection, where Linnaeus himself almost certainly worked to study that collection. Then at the beginning of the 19th century, the collection was split. The spirit material was transferred to the Royal Academy and hence the museum, and that's why the fetus is now there. But the dried material, including the teeth, went to Uppsala. The specimen was mentioned by Thunberg, who was cataloguing the collection in 1810, who was actually, by the way, a former student of Linnaeus. And the specimen to this day bears a label indicating that it did come from King Gustav Adolf's collection. So this is a Linnean specimen, and by token of the fact that it was a specimen that he had seen that formed part of his concept of the elephant, it can be considered a syntype, and therefore, and given that it is actually an Asian elephant tooth, although it's fragmentary, one can actually see that from its morphology. It is eligible as a lectotype. So, as a lectotype, it would have the advantage of actually being a Linnean specimen. It has the disadvantage that it tells you almost nothing about an elephant. It's a very small piece of one part of the animal. We go back to the elephant page of 1758, and then we finally come to the very first citation. We've left the best till last, if you like, which says Raj Quadra, page 123. This is Raja, and of course it refers to John Ray, the eminent English naturalist, man of letters, who of course was so important in the development of systematics. And this was his book called Animalium Quadrupedum, and when Linnaeus cites Raja Quadrupedum, he is referring to this book by Ray of 1693. Quadrupedal animals, also serpents, lizards and snakes and so on. And then we find on page 131, John Ray talks about the elephant. The whole thing is in Latin, but fortunately on our team we had people who were able to translate this. And there are pages, there's about 6 pages of anatomical description about the elephant by John Ray. Like Linnaeus, he did not distinguish African from Asian, and so it's a bit of a mixture. But among the various sources that Ray used for his information about the anatomy of the elephant was the skeleton which I saw in Florence. Now, John Ray, in 1660s, went on what became known as the Grand Tour. He spent about 4 years travelling around the great cities of Europe. He took with him a couple of his former students from Cambridge. And indeed, 20 years before the Quadrupedum, he wrote an account of his travels, 1673. You can skip down to the point, it's a chronological account of his travels, and in July 1664 they were in Florence. He said the Great Duke's Gallery, which is in the Uffizi Palace, a handsome pile of a building, in one of the rooms we saw the skin and skeleton of an elephant, which was shown in Florence some 8 or 10 years ago and died there. And so the description in the quadrupedum of the elephant by Ray is based in part on this skin and skeleton which he saw in Florence during his travels. Philip Skippen, who was one of his former students who accompanied him on his tour, also wrote his own account of the journey, and very usefully complementing Ray, and also happens to be in English, which is quite nice. It was actually published quite a long time after, presumably after Skippen's death in 1732. But he also gave a nice description. In one room is the skin of a young elephant, the skeleton we took notice of, and there's lots of details of the anatomy, some of which I'll come back to in a moment. Enrico Cappellini, who's been mentioned by Thomas, the protein guru, also happens to be Italian and also happened to have done his PhD in Florence. And when we got to the point in our thinking about the elephant-type specimens, that Ray and Skippen are talking about an elephant skeleton that they'd seen in Florence, it crossed Enrico's mind that there is an elephant skeleton standing in the museum in Florence today. But is it really plausible? I mean, lots of museums have an elephant skeleton in their gallery. Is it really plausible? It's 360 years after Ray described seeing an elephant skeleton in Florence that this could be the same specimen. Well, good old Ray and Skippen actually gave us quite a lot of clues to try and work that out. Further in the Latin, he says, in the skeleton that I saw in Florence, the sternum and the cartilages attached to it were missing. He further says, the teeth have parallel lines undulating. Those are the enamel ridges that you see on the chewing surface of elephant teeth, 8 or 9 of them. Okay. Now, this is thanks to our collaborators Anna-Marie Roos and David Cram, who did a lot of this historical sleuthing, especially in into the works of Ray and his contemporaries. Found a letter which Ray wrote in 1692 in which he made a few other comments about the elephant they saw in Florence. It hath properly no toes. This animal has the peculiarity of having no toes in its feet. Well, that seems a bit odd. And then if we go back to the passage from Skippen, I've actually marked in bold a few interesting passages. He says there were 6 neck vertebrae, the second and third joined together. And then there were 22 thoracic vertebrae dorsi, the 18th and 9th joined together in the process. That means the spinal process on the back of the vertebra. And so our colleague, we then drew in the curators at the Florence Museum to have a look at the skeleton for us, and the skeleton as mounted in the museum has a sternum and the cartilage is made of wood. Similarly, you'll remember that Ray said the skeleton has no toes. Well, of course, all elephants have toes, but this animal obviously somehow lost its toes in the process of being defleshed or dearticulated or who knows what. And they too are made of wood. So this seems to match Ray's and Skippen's description. Further, Ray mentioned that the teeth had 8 or 9 ridges on them. Now here are the molars in the jaw of the Florence skeleton, and they've got 8 very clear ridges and 2 rather faint ones at each end. And it could be anything actually, depending on the age of an elephant. There could be anything from 3 to about 25 of these enamel ridges showing. So obviously that in itself is not proof, but everything seems to match. Then on the backbone, sure enough, if you count them from the front where I put the red arrow, the 18th and 19th spinal processes are fused. So it seems almost certain, therefore, that the elephant described by Ray, having seen in Florence, is the very one still standing in the museum there. There's the sternum missing, the phalanges missing, the ridges on the molars, the vertebrae, second and third thoracic vertebrae. And then just a little addition is that someone who described it in the middle of the 18th century actually gave measurements of the skeleton which correspond very closely to measurements which our colleagues in Florence took for us today. the curators in Florence really got into this, and they started going back into their archives, because as well as the actual anatomical evidence that it's Ray's elephant, they were interested to see whether they could trace the history of how far back could they trace the history of the existing skeleton back through the records. And it turned out that remember that Ray and Skippon said that they saw a skin and a skeleton. Well, there's no skin in the museum at the moment, but what our colleagues found looking back in the original notes, that the earliest they could trace it back to was 1792, where the skeleton had the number 101 and the skin was there with the number 187, but that it is recorded that in 1837 the skin was disposed of, so that explains that. The skeleton then changed its catalogue number 6 times. Okay. But fortunately, every time the then curator changed the catalogue number, they wrote the old catalogue number as well as the new catalogue number, so they could trace the number all the way through to number 734, which is the catalogue number of the skeleton today. So it seemed very, very likely that the specimen described by Ray, cited by Linnaeus under Elephas Maximus, is the very one still there. But then there was one little glitch that really got me worried, in that on one page of Ray he actually talks about the penis of the animal. The penis in its sheath is described quite accurately, and the problem with that is that the Florence skeleton is very clearly a female. You can tell that because it's got virtually no tusks. It's got these little tiny things in its maxilla, which are known as tushes, which female Asian elephants have. Unlike the African elephant, in Asian elephants the females don't have tusks, only the males have them. Females have these little things called tushes. They have very less well developed maxillary bones than the males. You can also tell from the shape of the pelvis. The pelvic opening, as in many mammals, is wider in the female than in the male. These are 2 Asian elephants. The skeleton is clearly that of a female, and yet Ray was describing a penis. Again, thanks to our colleagues who were doing this forensic dissection of Ray's text, what they realised was that Ray's text is composite, in that although he included description of the Florence skeleton, he was also cutting and pasting bits and pieces from other people who had written about elephants. And it turned out that the section about the penis, among other parts of Ray's text, had actually been lifted from an account of another elephant published in 1682, an anatomical account of the elephant accidentally burnt in Dublin in the year 1681. I was puzzled by that title, and I looked up the original again. As Tom said, it's amazing what you can find on the internet these days. And the poor elephant, unfortunately, the shed that it was housed in caught fire, and this chap called Mullin, the elephant unfortunately burnt to death. Mullin, who then wrote this very long, detailed anatomical description with diagrams, as you see there, actually came along, and he said that the elephant was partly charred and partly parboiled, which is rather sad. But you can see immediately from the picture of the skeleton that it's a male. You can see that from the tusks, and Mullin even had the foresight to illustrate the penis, which is shown at the bottom of that there. So that explains why Ray was able to describe the penis. It doesn't mean that the Florence elephant had one, so that's all right then. So, in fact, what Anna Marie and David were able to show is that it's interesting that Ray's description was very composite. He brought together facts about elephants that he'd seen in Florence, the Mullins elephant from Dublin. He mentioned a tusk that was in Milan. He quoted Vartamanus in relation to tusks from Sumatra, and he even drew on some descriptions of the microstructure of teeth from the famous microscopist van Leeuwenhoek. The fact that Ray's description is composite and that Linnaeus cited Ray doesn't prevent one of the specimens that Ray described from being chosen as a lectotype. And so the conclusion of our study was that the skeleton in Florence be designated the lectotype of Elephas maximus. And of course, the curators in Florence are extremely happy about that. The thing's been standing there, or at least it's been in the museum for 360 years. They had no idea that it was a specimen which indirectly was cited by Linnaeus in his description of Elephas maximus. So that is a nice resolution of that story. And just as a coda to it, the DNA people in Copenhagen had a look at the genotype of the skeleton, the Florence skeleton, because to see where it came from. It's got a haplotype in mitochondrial DNA. It's got a haplotype called BP, or at least, sorry, the skeleton's haplotype is just one base pair different from one of the common haplotypes. This actually is a phylogeny of all Asian elephants, done by Vidya et al. 2009. It's a mitochondrial tree in which all of these different combinations of letters are different haplotypes. They identify different clades, and here you can see which array of different haplotypes. It's not very strongly geographically partitioned, unfortunately. You can't, in most cases, with a given haplotype, say, oh, it must have come from a certain place. And this BP haplotype, which the Florence skeleton is very similar to, is most common in Sri Lanka. There it is, at about 11%. But it is also found in other areas. It's found in Myanmar. It's found in Peninsular Malaysia. So it is plausible that the skeleton came from Sri Lanka, but we can't be sure of that from the genetic information we've got so far. And as a further link, this pen and ink drawing was made in 1655 of an elephant that died in Florence on the 9th of November 1655, and this is almost certainly the elephant that became the skeleton. And indeed Ray, in his account of his travels, I showed this before but I didn't particularly highlight it, he said, this was 1664 when he and Skippon were in Florence, he said the elephant was shown in Florence some 8 or 10 years earlier and died there. And since he was writing that about 1664, it means the animal must have died in 1654 to 1656, if that information is correct. So this illustration of a dead elephant in Florence in 1655 seems very likely to be the one that became the skeleton and became the type specimen. Right, I'm now going to tell you briefly about an elephant called Hansken. A famous elephant who was a performing elephant that toured Europe in the middle of the 17th century, and it became known as Hansken, and it's also known as Rembrandt's elephant for reasons you will see. Hansken was a performing elephant who could do all sorts of tricks. His most famous trick was he could draw a sword. You can see that in the illustration in the red box. And the story of Hansken has been very well reconstructed. There's lots of documentary evidence. Elephants were not exactly 10 a penny in Europe in the 17th century. It was, for almost everyone who saw it, it was the first time they'd seen an elephant or probably even heard about one. Can you imagine what it must have been like? And so the history of Hansken is very well known from a lot of documentary evidence. She arrived in Amsterdam in 1633 on a ship of the Dutch East India Company, and she was a gift from the Emperor of Ceylon to the Prince of Orange. She was a small elephant, said to have been born in 1630, so she was only 3 years old when she arrived in Amsterdam. Prince of Orange got a bit tired of it, gave it to someone else. I think his nephew got a bit tired of it, or realised that he could sell it, and sold it to someone for 20,000 guilders, which I gather was quite a lot of money. And the person who bought it called himself the Elephant Master. It was probably he who named the elephant Hansken, and taught it to do its tricks, and took it touring around basically to make money. There was an artist called Rembrandt in the Netherlands at the time, and he drew Hansken, and this was the first time that he drew Hansken. 1637, that is an illustration by Rembrandt of Hansken, which is in a museum in Austria now. In 1638, Rembrandt drew the elephant again, and this one you can see in the British Museum. This time he put some human figures there to give it some scale. If the birth date of 1630 is correct, Hansken was 8 years old at that time. Hansken catches a thief. This was an account that is in the literature. One of these great gatherings where people paid to come and see Hansken do her tricks. The elephant master, a woman cried out in the middle of the crowd, "Somebody's stolen my belt." And the elephant master said, "Don't worry, madam, Hansken will catch the thief for you." And Hansken walked around the room and eventually tapped a man on the head with her trunk, and the man protested and said, "I didn't steal the belt." So Hansken walked around the room again and came back to the same man and tapped him on the head again. And then somebody noticed that the missing belt was on the ground just next to this man's feet, as though he'd just dropped it. And so Hansken caught the thief. There was another story where the elephant master asked Hansken, "Who's been to the brothel?" And Hansken pointed at the priest. Because these may have been set up. So Hansken became very famous, and this is the third drawing by Rembrandt of Hansken, shown in 3 different poses in 1644. Not exactly sure when that was drawn. In 1646, another Dutch artist, not such a well-known one, also drew Hansken, and Hansken's looking a little bit the worse for wear here. She is not looking well. Her toenails look overgrown, her stomach is bulging. Well, I suppose in the middle of 17th century Europe, nobody really knew how to correctly husband an elephant. And of course she was being marched all over the place, large distances between gigs, to make money for her owner. So unfortunately she's not looking all that good there. 1649 to 52, she went on a tour all around Germany, Austria and Switzerland. This is a lot of walking. And there's a pamphlet in Germany of the time advertising her. There she is performing her famous trick with the sword. And then finally in 1655 she is recorded as turning up in Rome and performing there. And now we're coming full circle, because on the 9th of November 1655 a female elephant said to be 25 years old and to have come from Ceylon via Rome died in Florence. And this is the picture that I said must be the skeleton, but actually this picture is always referred to as a picture of Hansken. So these two stories are meeting from different ends. A contemporary in 1655 wrote that a female pregnant elephant, now that does puzzle me, but maybe it's because her stomach was very bulging, was conducted in Rome. It was trained to perform wonderful tricks with its trunk. That sounds very much like Hansken. Another contemporary said, and this is obviously after the skeleton was in the gallery, in the Uffizi Gallery there is a skeleton of a big elephant, but the point is that the same person in describing the skeleton goes on to describe Hansken, born in 1630 in Ceylon, brought to Florence and so on, and died in 1655. And then finally, another point from Skippen, which I hadn't mentioned before, that when they were shown the skeleton and the skin in Florence, they were told that when alive, the animal had been able to do all these tricks, including drawing a sword and all that. So I think there's quite a lot of evidence, partly apocryphal, but seemingly linking Hansken with the Florence skeleton. Another little bit of information is that going back to the molar teeth of the mounted skeleton, you can actually tell the age of an elephant quite accurately from its teeth, because elephants go through 6 sets of teeth during their life, and according to which set of teeth they're on at any given time and how worn it is, there's a scheme that's been quite well worked out based on elephants of known age, and that's shown on the right of the slide there. The mounted skeleton has its second molars in early to mid-wear, and that wear stage is the one that I put in red there, and I don't know if you can read it, but based on what's been done with known age elephants, it's about 26 years old, so that was the age of death of the skeleton. And remember, Hansken was supposed to be 25. She was born in 1630 and died in 1655. So all of these things seem to link Hansken with the elephant that died in Florence. They're both said to have been born in Ceylon. They're both said to have been born in 1630. The age is consistent with the tooth wear. They're both said to have travelled through Germany and Austria and so on. They're both said to have had their weight given as 6,600 pounds in the presence of royalty, and they're both said to perform tricks, including drawing a sword. So, although it's not 100%, unless there was another elephant in Rome and Florence at exactly the same time, which became the skeleton, we think it's extremely likely that not only is skeleton 734 a raised skeleton and therefore the Linnean type, which we've created as the lectotype, but how marvellous that we actually have a picture of it in life, drawn by no lesser an artist than Rembrandt himself. So, as both Tom and I have emphasised, this was very much a combined effort. We have the good fortune to be presenting this wonderful story to you, but an awful lot of people did a lot of absolutely essential work, both in the molecular work, in the archival work, and so a big thank you to all of them. I must say, for my part, it's been one of the most enjoyable collaborations that I've been involved in. So, thank you very much for your attention, and we're happy to answer your questions.